learned a long time ago. It's just I have a weird way of teaching it. Today, we're going to review another basic concept that you guys are already pretty good at, right, Josh? We're going to learn how to add and subtract fractions, which is pretty easy. So, you can't just add and subtract fractions the way that we multiply. You have to get a common denominator to be able to add and subtract fractions, which means the bottom has to be the same for both. Right now we have a 3 and a 4, clearly not the same. You want to find the lowest common multiple they share. So 12 would be the lowest. And if you're not sure how to do that, you just write out the multiples for each. So the multiples for 3 are 3, 6, 9, 12. Multiples of 4 are 4, 8, 12. We stop there because 12 and 12 are at both. You guys are pretty good at that. So, if you're looking at this first fraction, what do you have to multiply 3 by to get to 12? 4. So you multiply the top and the bottom by 4. What do you have to multiply 4 by to get 12? 3. Yeah, so you multiply the top and the bottom by 3. So that's going to give you 8 over 12 plus 9 over 12. Now you can just add the tops. You have 8 twelfths and you have 9 twelfths. You have 17 twelfths. No, we're not going to do any mixed fractions other than that. You're just going to write it like that. Nice and simple. You're going to simplify it if you can. But if you did this proper, you shouldn't be able to simplify. So if we had screwed up, and instead of multiplying by 4 and 3, we multiplied by 8 and 6, you wouldn't get the wrong answer, but you'd get an answer that you could simplify. 17 divided by 12 can't be simplified. That would be your answer. CJ. That's not a bad idea. It's just multiply right across. But if we look over here, we could get to 20 by only multiplying the first fraction, right? So the lowest common multiple these two share is 20, which means the fraction on the right doesn't need to change at all. The fraction on the left does. You have to multiply it by what? 4. Cute.
Sorry, so if, I don't know if this is doable, but like if the 9 was an 8 instead, could you just divide the 20 by 4?
Exactly, yeah.
Yeah?
Yeah, so you could always simplify your fraction first. Yeah, that would definitely work. It doesn't work here because it is a 9, but yeah, that's a great idea. You could always reduce one of them to be a common denominator. We're going to multiply this first fraction by 4. And the second fraction doesn't have to change at all. So now you have 12 over 20 minus 9 over 20. 3 over 20. These are all skills that you guys have learned along. When we start using variables, which is what we're going to do, it really doesn't change. Your skills are pretty much going to be the same. So, let's look at this next one. What's going to be the lowest common multiple between 6 and 9? 18. So multiply the first fraction by 3. Multiply the second fraction by 2. And you get 3 over 18 minus 14 over 18. And you get negative 11 over 18. Easy. The concept is the exact same for variables. Now all we have to be good at is multiplying variables, which we are pretty good at. So this is your nice little note page. Remember I said that these are going to start showing up where if you ever miss a class, you should have somewhere you can go and use that source. This is a pretty good source. This is how you're going to find common denominators for variable denominators. So if I have two equations right here, CJ, put your phone on. Don't bring it back out. If you have a common denominator here, the 6 and the 15 are both numbers. So you need to find a common denominator for the 6 and the 15. What would be their lowest common multiple? 30. It would be 30. Right? So we know that our denominator is going to be 30 something something, because we have x's and y's as well. What's the lowest common multiple for x and x squared? X squared. So whatever has the highest exponent, that's what you're going to go with. And the reason is we don't want to be able to try to divide an x out of this to get to x and x. That won't look good. It won't work out nicely. So you're always multiplying. You're always getting bigger. That's why you always take the biggest one. So then in our denominator, what would we have for y's? Just one y. Because that's the most number of y's that we get. So if you're looking at this first fraction, how is 6 going to get to 30? We would have to times it by 5. How is x going to get to x squared? We're going to have to times it by x. Remember with variables, when we're multiplying them, you add the exponents. So x times x is x squared. How is the y going to get to become a y? Just leave it. You don't have to multiply by anything. This second one, how is 2 going to become 30, or sorry, 15 going to become 30? So we're going to have to times by 2. How is x squared going to become x squared? It already is. How is no y going to become 1y? Times by y. It kind of does. So the top is just 5x plus 4y. 5x times 1, 2y times 2. They said it's not going to be crazy. This unit, for the most part, is going to be a lot of remembering what to do from 10C and 9 and 8. It's going to be a lot of remembering skills from previous years. If you're friends with anyone in Math 30-1 right now, they're working with this stuff on a much higher level. But if they don't have these basics like locked down, they're super struggling. Because what they do is they get graphs of this stuff and have to make equations out of the graphs. They make graphs out of the equations, which is tough. Right now, we're just working with this, which isn't too crazy. We're not going to simplify this. We're going to simplify this on the other page. Yeah, like after this next page. It won't take long. Go to that. Because we're simplifying right here. Same question right here. That's why I said it'll be on the next page. So, yeah, sure. Let's talk about that. Sorry about that. We're going to go through it right now. You have 3 and 2, the coefficients. So what's their common denominator going to be? 6. So how does 3 become 6? So multiply the top by 2 and the bottom by 2. Now, what's their common denominator going to be for the x squares? It's going to be x squared. So how does this first one get to x squared? It doesn't. You leave it. So the one on the left is done. The one on the right, how does 2 get to 6? Times it by 3. How does no x's get to x squared? Multiply it by x squared. So the top and the bottom get it. So that's what we're going to talk about. Okay. We're trying to get a common denominator. You have to do it piece by piece. You have 3 and 2. Numbers go with numbers. What's the common denominator between 3 and 2? 6. That one's easy. We multiplied this by 2 to get that 3 to become a 6. And we multiplied this by 3 to get that 2 to become a 6. But now you have to get a common denominator for your variables. This one has x squared. This one has no x's. You go to whatever is the largest number of x's. So x squared is the most number. Do we need to multiply this one by any more x's to get it to x squared? No, we're good. The one on the right, it doesn't have any x squared. So what are we going to multiply by to get x squared? Multiply by x squared. And what you do to the top, you do to the bottom. So if you multiply it by the top and the bottom, you're going to get 10 divided by 6x squared plus 3x squared times x is 3x cubed. Remember, you just add your exponents. So an x squared times x, 2 plus 1, x cubed. Divided by 6x squared. Now you can add these. It's going to be 10 plus 3x cubed all over 6x squared. And exactly, you add common terms, right? Like terms. There are no other x cubes. So the 3x cubed is stuck on its own. There's no other constant numbers. So 10 is just on its own. And the bottom stays what the bottom is. Okay? That's a great question. Now we need to talk about simplifying. And what a lot of people want to do is take a 3 out and take an x squared out. But this is addition. Addition, you can't do that. If it's addition, you have to be able to take it out of every single term. But you can't in this one. So that's as simple as it's going to get. That's your answer. It is missing one thing.
Restrictions.
It's missing a non-permissible value. So you go back to the original question, just like we've always done. You look at your two places you had division, one place, two place. What can't x be? X can't equal 0. Okay, let's do another one together. This one. That would be your final answer. There's nothing else you can do. Nothing can cancel because it's addition, not multiplication. And because it's addition, you have to be able to take that x out of everything, which you can't do. So you're stuck like that. This one, we already found what this looks like on the other page. So remember, that is just this. So it's 5x plus 4y.
Didn't see a minus on?
Yeah, it is minus. Thank you. Over 30x squared y. We did that on the last page. Right, and that's what I was going to say. That's what we're going to talk about. No, because x's and y's are different. Right? They're not like terms. And if we had a y squared, that's a different term. So you can't combine any of those. They stay in that exact format. Could we take an x out of these? No, because it's subtraction, right? You can't do anything. You can't divide a y, you can't divide an x, you can't divide a 4, can't divide a 5. You can't do anything. You're stuck. This answer is missing one thing. What's it missing? Our non-permissible values. Go back to your original question. What can't x be and what can't y be?
0.
Do you have to put it for both variables?
Yeah, you got to put it for both.
Just a little refresher. What makes it actually when it's not just zero?
Sorry, what makes x a natural number?
An actual number, like what it actually can. When it can.
Oh, if it was like this,
Oh.
right? That would make mean you're not, so I'd be 1, because then you'd be divided by 0.
If you're not adding or subtracting anything to x or y, it'll always be 0.
Yeah. Okay. These two, you should now be able to do on your own. You got about a minute to do them on your 3 minutes. Do it on your own. Quick review. Those should have been your answers. On the first one, you had to multiply the first fraction by 3 because your lowest common multiple was 21. And you had to multiply by an x, which gave you 6x squared on the top. You then had to multiply the 5 by 7, because that's on a 3 was going to get to 21. And you didn't have to multiply by x at all, because it already had an x on the bottom. The next one, exact same. A's and b's, same as x's and y's. Variables are variables. They all get treated the same.
Like, why do you it cannot
Because if you came back to this original question, and a was 0, 4 divided by 0 is not possible. So you just put that in to, like, remind yourself that that's what makes this true. Like, at this point, it's true, but not always true. By adding that in, now it's always true. Guess that's what I would look at. It'll really, really, really be useful next year with your graph of these things. Because that makes a world of difference. Okay. Because you're going to simplify these things. And when you graph it, it's not the same graph. So you're going to be able to know where what we call in that area holes are. And your calculator won't show you the holes. Your calculator will give you a continuous graph. But really, there's spots on the graph that don't work. It's kind of cool. And then they'll give you graphs, and you'll have to know what the equation is from the graph, based on the holes, stuff like that. Okay. This next one. The only thing that's more difficult here is if you look at the tops, they're no longer monomials. We have addition and subtractions on the top. It doesn't change things much, so it changes it a little bit. So we do need to talk about it, Ty. Yeah. I know. I want you to pay attention. The amount of time that you sit reading those little boards is crazy. There must be something awesome on that side. Okay. You find your common denominator the same way. That's not going to change at all. So, the 4 and the 6, what's their common denominator going to be? 12. So what do you have to multiply 4 by to get to 12? 3. So, times 3 times 3. What's our most number of x's we're going to have? X squared. This one already has x squared. So we don't need to multiply by any x's. The next one. What are we going to do to get 6 to 12? What are we going to do to get x squared? X. So I do this as my first step, and my second step, what I do is I go 3 times x minus 2, like that. Okay, and I leave it on the outside, and it's going to help me later. And then I go plus, and I go 2x, and I go x plus 6. All divided by my common denominator of x. Common denominator of 12x squared. The reason I do that is it'll help me on certain questions, but it'll never hurt me on any. So this question, if you didn't do that with these brackets, you'd be fine. Wouldn't make a difference. On other questions, the brackets make a big difference. So that's why I use them. It won't hurt me on a question like this, but it will help me on other types of questions. So just do it like this, yeah. Multiply your 3 into the brackets, multiply your 2x into the brackets. You're going to get 3x minus 6 plus 2x squared plus 12x. All divided by 12x squared. You then add your like terms. So x squares go with x squares. I only have one of those, so I have 2x squared. Plus x's go with x's, so 15 x's. And then constants go with constants, so it's just minus 6. And that would be my final answer. I suggest that whenever you look at something like that, you try to factor it. You can't factor this, so we're not going to try. Okay, awesome.
Like the first step that you wrote out there, if you have a 2x on its side, but then you have a 2x to multiply.
If there was a 2x,
Yeah, like how you have the 2x inside and you took it out, right? 2x plus 12x. Like inside, yeah, that was inside.
no, x plus 6 was inside, and I multiplied it by 2x because that was my to get my common denominator. That's where these numbers came from. I didn't factor them out. It kind of looks like that, though. It looks like I factored them out. I didn't factor them out. That's a good question. That makes sense. Okay, this next one. Look at your constants first. 2 and 9. What am I going to have to multiply this to get 18? 9. So times by 9. A squared. That's the most there is, so I don't have to multiply by any a's. B squared. How am I going to get b to become b squared? Times by b. So on the top and the bottom, I'm doing 9b. The next one. How am I going to get 9 to become 18? 2. How am I going to get a to become a squared? So 2a. How am I going to get b squared to become b squared? Don't do anything. It's already b squared. I'm going to write it out the same way I wrote the other one out. So 9b times 2a plus 1 minus 2a times b minus 3.
Okay, when you're multiplying it in, does it make it a negative?
That's what we're going to talk about. Okay. That should be where you're at right now. Oh yeah, the governors will die. Okay. If we're looking at this question, there's a reason we write it like this. And the reason we write it like this is that negative sign. This one right here. It needs to be multiplied into the brackets. And then you can get rid of the brackets. So that negative goes with that 2a. That whole thing is multiplied by each. That's why writing it this style is so important. So if we were to do that, the first one is easy. 9b times 2a would be 18ab. Then it's going to be plus 9b. But now, negative 2a times b is negative 2ab. Negative 2a times negative 3 is plus 6a. The negative has to go with it. That's the only way you can get rid of the brackets. If you didn't put the negative in with it, the brackets don't go away, which means we're not ready to combine like terms. Yeah, it's like 6 is a lot. Yeah. And it's divided by 18, a squared, b squared. Still on the bottom. Right, we're on 5.3. You want to spin your desk, that'd be nice. Yeah, it's a hard cue to use. Ty. Yeah, so by bringing that negative in, now it's basically plus negative 2ab, which is just minus 2ab, right? I'm not done. What do I have to do? Don't say non-permissible values. I gotta collect my like terms on the top. I have 18ab and I have negative 2ab. Those are the same, so that becomes 16ab. So there's 16 ABs on the top, plus 9 Bs, plus 6 As, and it's all still divided by 18 A squared, B squared. Now we're done. Non-permissible values. Okay. Anytime it's multiplied by something, so like these basic ones, almost always. We will get more complex. Just a heads up. But when it's basic ones like this, it's just 0. So,
just for like, say 16ab plus, if we would say 8 instead of 9, would you take a 2 out of every coefficients?
yeah. You always, as your last step, you're checking to see if you can simplify anything. I've always just been skipping that part because we can't. But it is something you should check. So you should look at that and go, can I simplify that any further? Can anything to be divided out of the top? Can anything cancel out in all the terms? And it can. Good question, John. Okay, these next two. Go on your own. You got another 2 minutes. The first one, our common denominator is 24x squared. We got that by going 8 times 3 and 12 or 6 times 4. You can see the steps there. You should have been checking your answer already. The next one, pretty easy actually. Our common denominator is going to be 15c squared d. So the second one only actually needs to be multiplied by 3. It's really nice. And this one has to be multiplied by 5c. Pretty easy. I skipped the step with the brackets and stuff like that. But after you multiply it into the brackets, this is what you should have. And I try to skip steps just so that you guys can see the board better. I know I run out of space often. Yeah, I'm bigger. Okay. Is this statement, so what they did there, the work they showed, is it sometimes true? Is it always true? Or is it never true?
I have a question.
And it says justify your answer.
When it has the x and then the comma y, does it mean that both of them?
Right. So x comma y, that's just saying they both can't equal 0. It's just a nicer way of writing it, a little lazier. But you will see that. Yeah, if you want to write it like that, you can write it like that. So we think it's true. Do we think no matter what values of a, b, x, y that we choose, that will always be true?
Okay, this is just for the equation, right?
Just for the equation there,
So
Lord.
that statement is true just against the equation.
Yes.
Of,
Yeah.
okay.
Is it true, and will it always be true?
I think so.
Is there any time it might not be true?
If the top was the way you're saying that, you're making me second guess myself as well.
I'm trying to make you second guess yourself. Megan?
It's negative.
No, so the numbers could even be negative.
Wait, if you get 0, you just not going 0?
You just can't divide by 0.
Okay.
And that's what it said, right? X and Y can't equal 0.
It's not always true.
So, the reason this question comes up is because CJ had brought up a good point, right? I think it was CJ, right at the beginning, that said, can't I just always multiply whatever's on the bottom of the other one? Because you said that, right? Yeah, first question of the day. And he said, can't I just always do that? Instead of trying to find the lowest common multiple, can't I just go back to this and be like, well, if I multiply all of that by 5c squared d, and I multiply all of this by 3cd, won't it always work? Which is what this question's asking you. If you just always take this part right here, and multiply it by the other one, and then always take this and multiply it by the other one, won't it always work? And it will always work. So this statement is true, and that's what they're trying to show you. That if you just want to take your denominator and multiply it across, it will always work. Here's the problem. It's not a very efficient method. And in math, you want to try to be efficient. That's how we end up spending hours and hours writing a test, is when we don't take the efficient route. The efficient route is lowest common multiple. But doing that will always work if you're ever really stuck. Yeah, you just have to simplify after. So, if you're ever stuck and you're ever like, I can't find the lowest common multiple, you can refer back to that trick and it will work. Okay. So, this one right here. The only difference now? There's 3 fractions. So that means now there's... Nope, you're going to do all 3 at once. You could. You could do them separately. You could just find the lowest common multiple here, bring that together, and then just find the lowest common multiple between the last 2 and bring those together. A little slow, but that's fine. Yeah, and you're never going to lose marks for that. Like, you're always going to be fine. It's just I want to show you an efficient way. So if you look at 3, 6, and 2, what's the lowest common multiple of 3, 6, and 2? 6. What do I have to multiply this first one to get to 6? And the last one by 3. The middle one, not by anything.
But don't you have to add the A's?
Yeah, now we have to do the A's.
No, but don't
So now, how are we going to get to A cubed? That's the lowest one. The first one, do I have to multiply by any A's? No, the middle one, what do I have to do? 1A. The last one, what do I have to do? A squared. So that is what you're multiplying everything by. The first one, 2 times 4 is 8. 2 times 3 is 6. A cubed. Plus, A times A is A squared. 6A squared times A is 6A cubed. Minus 5 times 3 is 15. A squared is still A squared. Divided by 6A. And you see, if you go one at a time and break it down like that, you get an x common denominator pretty quick. 6A cubed, 6A cubed, 6A cubed. It's the exact same thing we've done. Just one more term to look at. Bring those together. You're going to have negative 14A squared plus 8 divided by 6a cubed. And now, even though we did this properly, and even though we simplified to the absolute lowest thing we could have simplified to, we have a problem. You can simplify this further. Everything can be divided by 2, so you must divide everything by 2. So it becomes negative 7a squared plus 4 divided by 3a cubed. The reason that happened, even though we did everything properly, is because you had 3 terms being added together. It won't happen every time, but it could happen now. Where on previous questions, because we only had 2 fractions and we were doing things properly, it wouldn't ever need to be canceled out. Now that we have 3, we have to check at the very end for anything that could be simplified. Yeah.
Why don't you have to put this close?
Okay, so I skipped that little step, right? So you could do it like this. Everybody has that down written down? Like you could rewrite this. I'm going to do it in red. You don't need to write this down, I'm just showing you this. You could bring it over here. And on the top you could factor a 2 out, right? That's what you want to do. So 2, and you're left with negative 7a squared plus 4. And then on the bottom, you could factor that to be 2 times 3a cubed. And they cancel out. And that's why I just skipped that step. But that's why it works. And that's a great question. Because it looks like we factored. We did factor. We just skipped that step. Yeah, so if there was an a there, you do the same thing. Just bring an a out. And that could happen. And that's why I want you to check for that. Check if there's any factors or anything that can be divided out. Okay, I'm just going to write this part of the board so we do the next question. Actually, you guys do this. Start on your own. I'll put the answer on the board. Okay. This one's a little complicated. Great job, Bill. This one's a little more complicated, just because there's more things to multiply. So my suggestion is just try to keep things more organized. I ran out of space on mine, so it looks really ugly. As you can see, when you're not organized on these questions, how hard it can be. Your common denominator between 8, 3, and 6 would be 24. That's the lowest common multiple. Z squared is the highest number of z's you have. So that's what we're going to work with, is z squared. 8 times 3 gives you 24. You already have z squared on the bottom, so you don't have to multiply by any z's. So you multiplied the first one by 3. The next one, you have to multiply by what? 8. By 8z. The third one, what do you have to multiply by? 4z squared. That's where your z cubed comes from. At the end here, people were asking some good questions. They were saying, does it matter the order you write it in? It doesn't matter. In fact, the way you should write it would be z cubed first. So it would be 4z cubed minus 26z plus 3. That's fine though. It's the exact same answer. It's positive. Because negative and a negative, right? So if you use your brackets, you had to multiply that negative 4z squared in. Negative times negative gives you that positive.
Well, that's in Z, not in 2. I did that too often.
A good, no, our hurl keeper. A good trick is to write your Z's with the line through.
Yeah, that's for doing that.
And another one to do with your T's is to curl the bottom of your T. So it doesn't look like a plus sign. And X's, you're supposed to curl the top. Like that. That's how you. No. You should leave it. It's good for you. And if you change it to an X, as long as you don't change it, just change it back to the last step. Change it back to the last step. Say, do one more step. So if you're trying to match up your answer with a test, it's just different. And if you do it in a long answer, just switch, do one more step. Just switch it back. And then you're fine. I don't think I've ever docked you marks for that, but you should switch it back. Because it's not the stuff.
It is. It's still a non-known value.
Yeah. Okay. Unknown value stuff. But they're not, yeah, they're not the same. So, our last two questions. Multiple choice questions. Let's put our phones away. The way I would do multiple choice questions, and I've said this a few times, completely ignore your answers. Just answer the multiple choice question, then use the answers as like you're checking your own answer. So if your answer appears, you did it right. If your answer doesn't appear, you did something wrong, then you can go check through your work.
Or just go to the closest one.
Yeah,
Right?
I would suggest not doing that. But hey, I know a lot of people who do
I
that.
mean, if it says 120 and you got like 4,
And you're
I mean, you could go to like.
if you like put a 1 in your own value,
So
yeah, but I heard do and then you take that decimal and convert it to the same thing.
So Ryan has a really good question. Ryan's question was, could you just pick a value for A, plug it in, and find out which ones are the same? So if I said A was 1, and I put 1 in there and 1 in there, added them together, got a decimal, which is just 5, and put a 1 in for all of these, would it match up and would that work? So let's try it. We're going to put 1 in.
Okay.
So 2 divided by 1 is 2. 3 divided by 1 squared is 1. Plus 3 divided by 1 is 3 equals 5. Let's go to this first one. So we said A was 1. 5 divided by 1 is... Okay, let's go to this one. 2 plus 3 divided by 1 is 5. Let's go to this one. 8 divided by 1 is 8. Let's go to this one. 2 plus 3 divided by 1 is 5. So you get 3 answers that are all 5. Here's my suggestion.
Don't give up.
Never use 1, never use 0. Always use 2 or above, and your trick will work. 1 won't work. And I just wanted to make that a point, because I knew it wouldn't work. 2 will work. Or, simplify it really easy, this one just has to be multiplied by A, and you have 2 plus 3A over A squared is your answer, which is D. If you choose a number that's not 1, it'll work. 1 does weird things, 0s do weird things. Pick anything else, you're good. In fact, I would remember that trick for the rest of the year and for a lot of grade 12 and especially on your diploma. It works. Number 2. I'm not done. Number 2. Just simplify and then match up your answer after. Don't look at the answers. Don't try to do anything crazy. If your answer doesn't show up, then start resorting to different strategies. You have to multiply this one by 2. You have to multiply this one by x. So I'm going to have 5. I'm going to have 10. Minus x squared minus 6x. All divided by 4x. You'll notice that our answer doesn't match up anywhere. It's just in a different order. Different orders are fine, right, Ty?
Right.
B is your answer. Ty. No, we didn't multiply by negative 1. We just reordered it.
Yeah, you just get to multiply by second.